Hi, everyone. So this is the beginning of chapter 5, where we're going to take a look at a bunch of applications of integration, of integrals, and especially the business applications. So chapter 4, you learned how to evaluate integrals using a variety of methods, using tables, using substitution, and just, the antiderivative rules. Chapter 5, we're going to use integrals, but we're probably going to use, for the most part, technology to evaluate our integrals. So using our scientific calculator to do the evaluation is probably the main way we're going to do that. So I have a bunch of formulas here. So you want to have this formula sheet handy when you're doing the homework, because I want you to use these formulas. They're not formulas you have to memorize. But what you do have to do is understand the formulas and what they find for you, because you'll be asked to kind of interpret your answer or to label your answer with the proper units. Okay, so let's start with this idea of consumer and producer surplus. So this is an idea from economics. Consumer surplus is the total amount of money saved by consumers who are willing to pay more than market price and yet are able to get a market price. I think of this on a small scale of, say, wanting to go to a concert, and you're thinking in your head, okay, I'm willing to pay $500 for these tickets. I'm willing to pay more because I really want to go. But yet you find somebody that's like, hey, I'll give them to you for $350. So you have this savings of $150. So even though you were willing to pay more, you actually got it for the ticket price, right? So again, that's on a small scale. So graphically, I think is a great way to look at these, because if you understand the graph, it makes the formula make a lot more sense. So let's take a look at this picture here. So we have a supply function here. This is the function that's increasing. We have a demand function here. That's the function that's decreasing. So across the bottom, these would represent units or quantity. And along the y-axis represents price, so money. Okay, so your supply function is always in terms of price in terms of units, and same with the demand. And then the point where they intersect, right, which I kind of labeled QP, this would be your equilibrium point. Okay, we have worked on finding that before, so we know how to get an equilibrium point. So it's an ordered pair where it gives a quantity and a price at equilibrium. So many times they'll call that equilibrium point. They'll sometimes label it X sub E for, quantity at equilibrium, and then P sub E, so price at equilibrium. Okay. All right. So when we want to find the consumer's surplus, you can see the area highlighted in blue. This is the consumer surplus. It's the area under the demand function, yet above the price. Okay, so again, keep in mind this line right here is our price. So if you want to find that area, if you just think about finding area between curves, it's the upper curve minus the lower curve. So you would just take the integral, and again, you have to integrate up until this x value here, which is your equilibrium point, and just do upper curve minus lower curve. So it would be the demand function, d of x, or, depending on what variables they use. So we'll just say that's the d of x function minus the lower curve, which would be the price function. So to find that consumer surplus, if you just think of it as being upper curve minus lower curve, that makes sense that that's our formula. And then where do we integrate to? Well, for the consumer surplus, you have to integrate from 0 over to the quantity. So 0 to that equilibrium quantity, I could call it Q, or X, depending on the problem, right? Okay, so I did give you 2 different consumer surplus formulas. Again, there's a variety of ways to do it. I typically use this one because I like to think of it in terms of the picture. It's just the upper curve minus the lower curve. But you can also use the other formula, which is somewhat of the same idea, where you take the integral of the demand function, so that gets you all the area under the demand function, and then you subtract out from that the little box, which is the revenue. Okay. All right, so here goes. Let's give it a shot. So you have this Chandra scooter. She's determined a demand function, and it's given by this d of x here. And so x is the quantity demanded, D of X is the price. Assume the market price is 350. Okay, so I'm going to make a little note here. So the price at equilibrium is 350, and we want to find the consumer surplus. Okay, so I'm going to use that formula from up above. I'm going to use the formula where I'm going to, take the demand function minus the price. Okay, so I'm going to use the demand function, subtract the price, dx, and I'm going to integrate from 0 to the equilibrium quantity. Now, that's something I don't have just yet. Let me fill in what I do have. I know that I'm going to integrate from 0 to the demand function, which is negative 0.25x plus 420, minus the price, which is the equilibrium price, 350. So all of that I'm going to integrate, and then up to the equilibrium quantity. Now, I don't know that quantity, but I can find it, right? So call it Q, or you can call it X at equilibrium. So I need to find the X value that goes with the price. Well, that can be done because I have an equation here. I know this equation, D of X is negative 0.25x plus 420. So what I need to do is find X. I know the price, because remember D of X stands for the price here. So I know the price is 350. Let's set that equal and find our equilibrium quantity. Okay, so we just have to solve this for X. So again, little algebra here. Let's move our 420 to the other side. Let's solve this thing for X, right? So let's see, this will give me negative 70 equals negative 0.25x. Let's divide by negative 0.25. Okay, and again, use your calculator here. And so you find out that the X, or the quantity at equilibrium, is 280. All right, so actually my equilibrium point is 280, 350. Now I can now use this 280 and put it here for my quantity. Now I'm ready to go. So my consumer surplus is going to equal the integral from 0 to 280 of negative 0.25x. Now let's combine these like terms here. Let's do the 420 minus 350. That'll just make it easier to type in. So if I subtract that, I actually get 70 plus 70 dx. Okay, so this would be my integral that I need to solve. And I'm just going to use my calculator. I'm going to type that integral in the calculator, and I will get my consumer surplus. Now, the work you show is just exactly what I've shown here. I'm not going to show the work of getting my integral because I'm going to use my calculator. Okay, so I'm going to put a little note here. I'm going to use the calculator, and I'll show you what it looks like, typed in my calculator. But again, the main thing is you have to show me what integral you're typing in your calculator. So that's why I've written down, right here, here's the integral that I'm going to use. All right, so let me scroll up here. I've typed it in my calculator, and here's what it would look like. So again, I'm using my integral button, which is right here. You have to hit second, and you choose that button, and then you enter the 0 to 280, and the function, hit enter. Sometimes integration takes a minute on the calculator, so sometimes you have to wait a second or two, and then it gives you 9,800. Okay, so back here, I've got my final answer. Now remember, consumer surplus is a money amount. So this is 9,800. So this would be the consumer's surplus here. Okay. So there it is. So again, in this chapter, use your calculator to evaluate your integral. You do not need to do these by hand. All right. So again, keep in mind the picture. So again, what I just found was this area under the demand function above the price function. Now, when I do producer surplus, you can see the picture is a little different. I'm going to be finding the, this pink area here. So I'll be finding the area under the price function. So that'll be my upper curve, but above my supply function. And so for producer surplus, if you look back here, the formula that we can use for producer surplus is this guy. The area under the price function. So the price function is like my upper curve. And the supply function is my lower curve. So it's just upper curve minus lower curve like we've done for the other area problems. And I know in your econ class, you probably end up having to kind of memorize this graph and know where each surplus is at. So hopefully you've had that econ class, and it does definitely make this a little bit easier. Okay, so let's keep going. Let's try another problem. We've got our first consumer surplus done. Let's try the next one. Okay, example 2. You have an office house, a supply store determines the demand is given by d of x, 30 minus x, and the supply is the square root of x. Okay, and of course the demand and supply are in dollars. Find the equilibrium point and determine the consumer and the producer surplus. Sketch the graph of the situation. Okay, I like sketching the graph because it helps me visualize what I'm doing anyhow. So let's just start. And again, you could use Desmos to help out with the graph if you like. But I know the square root function, what that looks like, right? That's just the eyebrow shape. So this would be my supply function is the square root of x. My demand function, 30 minus x. Well, 30 minus x, that's a line that would start at 30 and, kind of shoot downward. Now, again, you can use Desmos or any other graphing device to help you with this graph. That's fine. So here's my demand function, d of x. And so the first thing I want to do is find my equilibrium point here. And so I'm going to do this with a little algebra. If you want to find where those two graphs intersect, what you would do is you would set them equal to each other. Okay, so my equilibrium point is where they're equal. So I'm going to take square root of x and set that equal to 30 minus x. I'm going to solve that. Now, this is a little bit of fun algebra. This is going to take some creativity on your part. In order for me to get rid of that square root, what I'm going to have to do is start by squaring both sides of this equation, right? Because squaring is the inverse of the square root. And so if I square, this side just becomes x. Now, when you square 30 minus x, there's no shortcut for that. You have to FOIL 30 minus x times 30 minus x. So what I would do is just pause it here and do your FOIL on this, okay? All right, so if you do the FOIL on that, you're going to end up with this, a 900 minus a 60x plus an x squared, okay? And then because we have a quadratic, we're going to get it equal to 0, so I'm going to move this x over here to join. And so I'm going to have 0 equals, and let me put this in a rearranged order. I like the x squared first. That'll be minus 61x plus 900. Now you can try factoring if you like. I'm just going to use a quadratic formula on my calculator. Okay, so I'm going to use my quadratic formula on my calculator. I've shown you that before, so that's kind of a nice feature. And by the quadratic formula, you're going to get two answers. One answer is going to be 25. And the other answer is going to be 36. Now, we can't have two equilibrium points, but there is an issue with one of our answers here. If you recall, our demand and supply functions are given to us, and they each represent the price, right? So if x was 36, so there'd be a little trouble with x being 36, because look up here at this, demand function. If x was 36 and you plug 36 in there, you would end up getting a negative price. So 36, we can't have 36 for our quantity. It gives a negative price, but 25 would be okay. All right, so back to my graph here. I now know that this intersects right here at the x value of 25. And now I can plug that x value back in to either function and get the y value. Okay, so let's say I plug it into S of X. So S of X is the square root of X. So if you plug in 25, the square root of 25 gives you 5. So the Y value here is 5 for your equilibrium point. So our equilibrium point is the quantity 25 and the price 5, right? So let's remember, this is quantity across here, and this is price over here. Okay, and you want to make sure you label your axes when you're doing that. So this is my X value, and this is my price. Okay, whew. So I got the first part. I've got my equilibrium point here. Now we're supposed to set up and find our consumers and our producers surplus. So that's easy enough to do. I'm just going to set up the integral and then use my calculator to evaluate. So let me shade where they're at. So let's start with the consumer surplus. I'm going to shade that. That's going to be here in green. And so this is my consumer's surplus. So let me set up the integral for that. Consumer surplus, I can see by the picture, is going to be the integral. The upper curve is the demand function. So that's 30 minus X. And the lower curve is the price function, which is 5. So upper curve minus lower curve. And then I'm going to integrate from 0 to the quantity 25. So again, I don't really even memorize the formula if I know where it's at on the graph. But again, what formula I'm using is I'm using the formula that says you take your demand function d of x and subtract your price. Let me clean this up, and then we will type it in our calculator. So the integral I'm going to put in my calculator is going to be 0 to 25. I'm going to do a little combining of like terms. So I have a negative x and then 30 minus 5 plus 25 dx. Okay, so we're going to put that in our calculator, and then you're going to get a consumer's surplus. So take a minute, enter that in your calculator. I'll tell you what you should get. You should get a dollar amount, right? This is money of $312. And because it's money, I'm going to say 50 cents. This is our consumer's surplus. Okay. And again, the work I show is just setting up the integral. So I'll always ask you to set up the integral, and then you can use your calculator to evaluate it. Okay, let's get the producer's surplus. So let me go over here on the graph again and shade where that is at. So the producer's surplus is this area below the price function, but above that supply line. So this area in red here, I'm going to label that as my producer's surplus. So let me write an integral for that producer's surplus. So again, it's an integral, and the upper curve is the price function. So it's going to be 5 minus the lower curve is the supply function, which is the square root of x dx. And I'm going to integrate from 0 across to 25. Right? So again, I'm using the formula that we take the price and we subtract the supply function. Okay, so there's not really a lot of cleanup here. Maybe I'll just drop a set of parentheses. So I'm going to integrate from 0 to 25 of 5 minus the square root of x. Now, again, if you prefer to use the other formula, you can do that. Then your integral will just look a little different, but your final answer is going to come out the same. Okay. All right, so here's what I get for my producer's surplus. When I input this integral in my calculator, I get that the producer's surplus is $41, and because it's money, I'm going to round 67 cents. There he is. Okay, there's your producer surplus. So maybe I better spell that out in words here. So this is my producer's surplus. Okay. So wow, this problem has about everything in it. It's got the picture that we have to draw. We have to label the parts of it. Notice I label my X and my Y axis and so on. And then we set up our integrals and get our values. Okay, one last problem here. And this one has a little bit of a trick at the end. So I definitely want to give you this example here. So it gives you a demand function and it asks you to find each of these four quantities. And it does make a hint. It will help to sketch the graph. And I 100% agree. I think it's essential that you sketch the graph. So the one in the homework, you definitely want to look at the picture of this. So for the picture, use Desmos. Let's draw a little graph here. We have this demand function, this negative 0.013Q plus 55.9. So it's going to be this function that has a y-intercept at 55.9. It's a linear function. It has a negative slope. So it's going to slope down. So again, use Desmos and you'll see the picture. And I want to draw the picture far enough that I can get where it intersects this x-axis here, which for this one, it actually intersects right here at 4,300. Now remember, the x-axis is the quantity, while the y-axis is our price. Okay, helpful to label that. So this is the picture. Now, the first question, let me label this. This is my D of Q also, demand function. Find the actual revenue when the quantity is 800. Okay, let me draw it on the picture. So if the quantity is 800, so I'm going to say that's about here somewhere. There's a quantity. Let's draw a little line up here. So if this is my quantity, I could plug in 800 and I could find the price that goes with 800, can't I? So if you plug in the quantity into the demand function, let's get the price. So the price is going to equal your negative 0.013 times the quantity, which is 800, plus the 55.9. So let's get the price that goes with the quantity of 800. So if you plug that in, you're going to come up with that the price is 45.5. That's the price that goes with the quantity of 800. So let me label that on here. So over here on the picture, we've got 45.5. Now it says find the revenue. Well, how do you get revenue? Remember, revenue is quantity multiplied by price. So if I want the revenue, I'm just going to take my quantity, 800, and I'm going to multiply it by my price, which is 45.5. What I'm getting as far as the picture goes is I'm getting this area right here. So this little blue area, that is my revenue. Okay, that's the revenue right there. So if you plug it in, 800 times 45.5, you will get that your actual revenue there, okay, 36,400. There's our first answer. And it helps to have the picture so you can kind of see visually what you're finding, right? Okay, now the next thing says, find the total possible revenue for all quantities and prices. Okay, total possible revenue for all quantities and prices. What that would be, if you want the total of all the revenue, it would be the area, the full area under this demand function. Okay, so this would be, I'm going to just put it this way, the total area under this demand function, under d of x, right? If you look at it, it's a big triangle, isn't it? Now we can get the area by doing an integral, or gosh, why get complicated? If we want the area under that demand function, it's just a triangle. Why don't we just do a 1/2 base times height? Okay, but again, if you want to be fancy, you can set up an integral and do the same thing. But I'm going to just do it by area of a triangle. Okay, so area of a triangle, 1/2 base times height. So again, the triangle I'm finding is this big triangle right here, outlined in green. So 1/2 base times height would be 1/2, and the base across the bottom there is 4,300. And the height up above the side, 55.9. Again, those numbers, because you have Desmos and you have a perfect graph in front of you. So if you want to get the total possible revenue for all the quantities, so the quantity all the way to 4,300 and the price all the way to 55.9, then you're just going to type this in, little area formula, and here's what you should get. You should get a money amount of, it looks like 120,185. That would be your total possible revenues. Okay. Okay, now next, find the consumer surplus when Q is 800. Okay, consumer surplus, let me highlight that on our picture. Remember where the consumer surplus is. It's right up above the price function. So I'm gonna highlight it here in purple. So this would be my consumer surplus that I wanna find, which again, you can do by integral, or because it is a triangle, you can do a little area of a triangle formula, right? So if you like your geometry a little better than your calculus, you have options now. I'll set it up with the integral. Let's do that here. So let's get our consumer surplus. So that's going to be the integral from 0 over to 800, right? Because that little purple triangle goes 0 to 800. I'm going to put my 0 here. And let's see, the upper curve is that demand function. So that is our negative 0.013 Q plus 55.9 minus the price function, which we found 45.5. So I'm using the formula where I take my D of X and subtract my price. Okay, again, look up on the formula sheet. And then I integrate from 0 to the quantity at equilibrium. Now you could type this in your calculator, or if you'd like, you could, simplify it a little bit and then type it in your calculator. Whatever your preference is, I'll let you do that. But here's the answer you should come up with. For your consumer surplus, you should get a money amount, right? Label it dollars, $4,160 for your consumer surplus. And you can see it on the picture, right? Okay, so now here's the tricky question that can be tough because we really haven't talked about this. So that's why we need to talk about it here, where it says find the not sold value corresponding to a quantity of 800. So if you sell a quantity of 800, we see the consumer surplus. So when they're talking about the not sold value, they're talking about this section right in here. Okay, so I'll highlight it kind of yellow. This would be the quote unquote, the not sold, value or quantity for Q is 800. Right, so if your quantity is 800, this little section here would be the not sold area. Okay, now, again, you have two ways to get this value. It's a triangle. You can do area of a triangle, or we can do integration, right? Integration gives us area under the curve. Well, let me set up. I'll do an integral for my not sold section. Okay, so not sold, so to speak. So if I want that area kind of highlighted in orange there, I'm going to have to do the integral starting at 800 and going over to 4,300. And I'm going to be getting the area under the curve, which is the demand function, which is negative 0.013 Q plus the 55.9. Oh, dq, sorry. You know what? I put dx on that other one where my variable is actually q. I got to be careful with that. So this is how we could find the not sold area with a integral. Or like I said, you can also do it by a little area of a triangle formula. Whatever makes it easier for you. Well, I'll tell you what the answer should be. It should come out to 79,625. Okay. So these are some examples of how we can use our integrals to find producers and consumer surplus. Again, you have a formula that's given to you. You just have to follow that formula and then use your technology, your scientific calculator, to evaluate your integrals. But the work you show needs to be like what I have here, where you set up your integral and then get your value and label your answer. Okay, I'll see you next time.